Hello guys, today we are going to discuss two important concepts of a quadratic equation. First concept is what is represented by a quadratic polynomial, and we have second concept, that is we have to find the maximum or minimum value of a quadratic polynomial. So let's start with a quadratic polynomial. Y is equal to ax square plus bx plus c, where a and b are real numbers and a is not equal to 0. If a equal to 0, then this polynomial reduces to linear polynomial. Now using completing the square method, we change this into a square term. So first take a as a common term, we get a multiplied by x square plus b divided by a x plus c. Now we add and subtract b square divided by 4a square, we get y is equal to ax square plus b square divided by 4a square plus b divided by ax minus b square divided by 4a square plus c. We see these three terms make a square. It means a multiplied by x plus b divided by 2a whole square minus b square divided by 4a plus c. We can write this as y is equal to a multiplied by x plus b divided by 2a whole square minus b square minus 4ac divided by 4a, or this can be written as y plus b square minus 4ac divided by 4a is equal to a multiplied by x plus b divided by 2a whole square. Now if we write b square minus 4ac is equal to d, that we have studied in 10th class, that the discriminant of a quadratic equation is b square minus 4ac and it is represented by d. So this can be written as y plus d divided by 4a is equal to a multiplied by x plus b divided by 2a whole square. Now this equation 1, if we see it, this is in the form of capital Y is equal to small a multiplied by x square. This is a parabola. It means the quadratic polynomial represents a parabola. So the answer of first question is parabola. Now what is the vertex of this parabola? If I see this clearly, then we get minus b divided by 2a comma minus d divided by 4a is the vertex of this parabola. Now we know that this parabola can be either concave upward or concave downward. This property depends on the value of a. If a is greater than 0, then this is a concave upward parabola, and if a less than 0, then this is a concave downward parabola. So basically using a, we can have 6 possibilities. So the 6 possibilities depend on a and d. First condition, first consider that we have a is greater than 0. When a is greater than 0, we can have 3 types of graph. First is this one of equation 1, and second graph can be like this, and third graph can be like this. Here we see that the equation 1 cuts x-axis at 2 points. It means we have two values of x for which y equal to ax square plus bx plus c have 2 zeros. It means in this case d is greater than 0. Here we have only one value of x, and for which this quadratic polynomial is equal to 0. It means we have only one 0. In this case we have d equal to 0, and third case we have no value of x for which we can say there are exist any zeros, so we have d is less than 0. This thing we have studied in class 10th. Now there are 3 cases according as a greater than 0. Similarly, for in part B, when a is less than 0, we have three cases of concave downward parabola. First one is this, second one when it touches x-axis, and third one when this quadratic polynomial cuts x-axis at two distinct points. In this case, we can say d is less than 0. In this case, we can say d is equal to 0, and in this case we can say d is greater than 0. Now we have all six cases, so let's see all these six cases in one window. Here this case and this case are two of very important values. For this case, this is the graph of y equal to ax square plus bx plus c, and we can say y is greater than 0 for every x belongs to R by seeing this graph, because this is above x axis for every value of x. And in this case, y equal to ax square plus bx plus c, where y is less than 0 for every x belongs to R. It means the y is negative everywhere for any value of x. So here for all these three cases we can say that the vertex have the minimum value, and in the case of a less than 0 we can see that vertex, it means this point and this points, have the maximum value for y equal to x square plus bx plus c. Now these six positions are very important, so let's start by making some notes. First note, y is greater than 0 for every x belongs to R if a is greater than 0 and d is less than 0. Second, y is less than 0 for every x belongs to R if a is less than 0 and d is less than 0. These two are very important. Now third concept, the minimum or maximum value of a quadratic polynomial exists at the vertex. When a greater than 0, it means concave upward parabola minimum value exists. And it is equal to minus d by 4a. It means it's the y coordinate of vertex. For a less than 0, it means concave downward parabola maximum value exists. Maximum value exists and it is equal to minus d divided by 4a. It means y coordinate of the vertex. Now I will solve one question here. We have a question, and what is the question? Find the set of values of a. Find the set of values of a for which the quadratic polynomial a part a plus 4 multiplied by x square minus 2ax plus 2a minus 6 less than 0. Now we will solve it here. There can be two type of graph for this polynomial. Since a plus 4 multiplied by x square minus 2x plus 2a minus 6 should be less than 0 for every x belongs to R, it means we need this type of graph. So basically we need the coefficient of x square less than 0 and d is also less than 0. It means we have a plus 4 is less than 0 and at the same time d should be less than 0. We get a plus 4 less than 0 and b square minus 4ac. It means 4a square minus 4 multiplied by 2a minus 6 multiplied by a plus 4 is less than 0. Now if we simplify it, we get a less than minus 4 and 4a square minus 4 multiplied by 2a square plus 2a minus 24 is less than 0. Take 4 as a common term and divide whole equation by 4. We get minus 4a square minus 8a minus plus 96 less than 0. When we divide by this by 4, we get a square minus 2a plus 24 is less than 0. Multiply both sides by minus 1, we get a square plus 2a minus 24 is greater than 0, or it implies that a square plus 6a minus 4a minus 24 is greater than 0. We get this is equal to a minus 4 multiplied by a plus 6 greater than 0. We represent the critical points on x-axis. This point is minus 6, this point is 4, plus minus plus. We get either a belongs to minus infinity to minus 6 union 4 to infinity. If we take the intersection of this with a less than minus 4, or we can say that a belongs to minus infinity to minus 4, we get the intersection of these two, a belongs to minus infinity to minus 6. Here we have an open interval. So the answer of this question is minus infinity to minus 6 open interval. In second part, we have a quadratic polynomial, that is a minus 1 multiplied by x square minus a plus 1 multiplied by x plus a plus 1 is greater than 0 for every x belongs to R. It means this quadratic polynomial should be greater than 0 for every x belongs to R. We want this case. For this case, coefficient of x square should be greater than 0 and d should be less than 0. It means if we solve it, we have a minus 1 is greater than 0 and d is less than 0. So first we solve it for d. A plus 1 whole square minus 4 multiplied by a plus 1 multiplied by a minus 1 is less than 0. We simplify it, we get a square plus 2a plus 1 minus 4a square plus 4 is less than 0. We simplify it, we get minus 3a square plus 2a plus 5 is less than 0. Multiply both sides by minus 1, we get 3a square minus 2a minus 5 is greater than 0. Now if we factorize, we get a plus 1 is multiplied by 3a minus 5 is greater than 0. Represent the critical points. This point is 5 divided by 3, this point is minus 1, plus minus plus. So by d less than 0, we get a belongs to minus infinity to minus 1 open interval union 5 divided by 3 to infinity. From this we have a is greater than 1. So if we take the intersection of these two, we get a belongs to 5 divided by 3 to infinity. Thank you.